Okay, today we're going to figure out how we do questions that deal with acceleration, but when the acceleration refers to things falling, and we got gravity being the acceleration instead of the normal questions we've been doing. So the key thing that you have to understand with gravity is that all things fall at the exact same rate. So in the old days, they used to think that things that were heavier, like a brick, would fall faster than a feather. So because when you did it, the brick would fall and the feather would sort of float down slowly. But Galileo figured out that it was due to air resistance that was causing that. So if we made everything the same shape and size, that they would fall the same. So he had a famous experiment where he dropped a lead cannonball and a wood cannonball the same size, so a big lead ball and versus a light wood ball. And he dropped them from the Leaning Tower of Pisa in Italy, and they did hit the ground at the exact same time. So in class, when I showed you this, we used like a piece of paper and a pen, and then I crumpled up the paper, and they both fell at the same time. So the key idea to remember is that gravity will be the same in all times. It's always going to pull things downwards to the surface of the Earth, and the rate that we've calculated over the years to be the most accurate is 9.81 meters per second squared. So you're always going to use 9.81 for all your calculations. A couple of key things you got to be careful of when you're doing these is if the object is moving upwards, you want to think of that upwards motion as being positive. So if the thing is getting thrown upwards, that'll be a positive velocity. If it's moving upwards, you got a positive displacement. And then if it's going down, that is our negative. So if it's falling, you'll have a negative velocity, negative displacement, and because acceleration always points downwards, we're always going to use negative 9.81. So it doesn't matter if the object is moving up, the acceleration is always pulling it down, so the A will always be negative 9.81. So let's do a couple examples. So the first one here, you can see it says a ball is thrown upwards at 16 meters per second. We want to know how fast it's going after 2.8 seconds. For a question like this, we know the ball is going to then go up. When it hits the top, it stops for a split second, and then it turns around and falls back down. So for this question, we don't know whether the ball is moving up or down where that 2.8 seconds is. It could be maybe somewhere in here, so it'd still be moving upwards, or maybe the 2.8 is somewhere over here, and then it's moving down. The good part is the formulas will take care of that as long as you put in all your minus signs and everything correctly. So if you make your list, you can see we got VI is 16, time is 2.8, our A is 9.81, we're looking for VF. So the formula without distance is the one I've got written on here, the A equals VF minus VI over T. So all we want to do is plug in those numbers, so negative 9.81 will equal VF minus 16 divided by 2.8. So just cross multiply those to get rid of that fraction. So negative 9.81 times 2.8 gives you negative 27.46 or 47 if we round it off. And that'll equal VF minus 16. So then the last step is just add 16 to both sides. So we end up getting, so minus 27.47 plus 16, we end up getting negative 11.47. And if you look at the question, we want 2 sig digs. 2 is the least. So then we just say our VF is negative 11 meters per second. Okay, so let's go back to what I was talking about. So we don't really care whether it's going up or down or whatever, the math will take care of itself. So because we're getting an answer of negative 11, that means then that the ball is already gone up, it's hit the top, and is already falling down, so it is somewhere in that location. It's not quite at the bottom yet, because if it was at the bottom, we would be at 16 again. It'd be negative 16. Okay? I'm going to talk about that more in a second. So the next example, same sort of thing. You can see a ball is going upwards at 12 meters per second. The question is how long does it take to reach the maximum height? Then I want to know how high does it go? And then after that, how fast is it going when it hits the ground? So we'll go through sort of all 3 scenarios one at a time. So the first part, we got our VI of 12, our acceleration still negative 9.81. The question is how long is it going to take? So we're looking for time. And it seems like we're missing some information here. We don't seem to have enough. But the key thing is with these kind of questions, you have to remember that if it's going up at 12, so if it's starting at 12, when it hits that peak where it's going to stop, then your velocity is going to be 0. So that's what we want to use for a VF. Put a VF of 0 in, because it's going to stop when it gets to the maximum height, and then we should be good. So in that formula, if we plug it in, we'd have negative 9.81 will equal 0 minus 12 divided by t. So we bring the t up, so we'd have negative 9.81 times t equals negative 12. So just divide negative 12 divided by 9.81, and that gives you a time of 1.22 seconds. And we want 2 sig digs because we only have 12 in the question, so everything should be 2 sig digs, so we'd just say 1.2 seconds. Okay, so that means it took 1.2 seconds to get to the top. What we're going to find out is if we were then to figure out how much time it took to fall, we'll get the exact same answer. So the key thing to remember with this stuff is it'll start at 12, it'll go up. When it gets to the peak, it'll have a speed of 0, and the time that it took to do that, so in this case 1.2 seconds, that is halfway through the trip. So then when the object falls, it'll start at the speed of 0, it'll end up at a speed of negative 12, and that'll take 1.2 seconds again to fall. Okay, so that's always exactly halfway through. So the first part we did, the second part says how fast is it going, or how high does it go. Then the last part is what is its speed when it returns. So we've already answered that one. So our returning speed will be negative 12 meters per second. Okay, so the only thing we've got left to figure out is how high does it go. So what we want to do for that one is solve the question again, but now let's solve it for distance. So let me erase this, and we're going to redo the question. We got our velocity still. We now know that its time is 1.2 seconds, but let's try not to solve the question using that answer just in case we made a mistake. Let's try solving it for the distance when we got VI, A, and VF. So the formula we want will be VF squared equals VI squared plus 2AD. Okay, so we plug all those numbers in. We know at the top it comes to a stop, so we'd have 0, and our VI was 12, and our A is 9.81, negative 9.81, and we want to solve it for D. So if you do the math on all this, we'd have 0 equals 144 minus 19.62D. We can bring the 144 over, so you'd have negative 144 equals negative 19.62. Divide those out, so negative 144 divided by 19.62 gives us a distance of 7.34, or if we do 2 sig digs, 7.3. Okay, so we know that it went up 7.3 meters, and we could do the calculation again if we wanted to, and we'd find out that it falls 7.3 meters downwards. Okay, so that's sort of the key ideas for these questions. Pretty basic, just basically remember to always use negative 9.81, and then just remember at the top we get a speed of 0. That's sort of the key idea. One last topic to deal with, or to make sure you understand, is quite often you'll hear the term G's, so it'll say somebody underwent 3 G's of force, or in space terms quite often they call it Gforce. So all that means is we're just comparing whatever acceleration that is being felt by the person that's moving and how that would compare to the Earth's acceleration of gravity. So if you had 5 G's, that just means that you've gone 5 times the normal gravity, and that's what your body would feel. So if you're on a roller coaster ride or something like that that has G-force, your body, you feel pressed, like you're pushed down into your seat or whatever. So that's what you're feeling, is that G-force. So sometimes instead of figuring out a number, it doesn't really make sense. So in this case, 49.1 acceleration, meters per second acceleration, you might not understand what that would mean. But if we divide that out by 9.81, you'd see that it's 5 times stronger than gravity. So if you're on a ride that has 5 G's, you're really going to feel it. You're going to feel squashed in your seat. Some people actually black out, because most people, they can only handle up to about 5 G's. Anything beyond that, usually you can black out. And the reason for that is the force of gravity, or the force that you're feeling, is pushing the blood down in your body, and your heart isn't strong enough to pump it up to your brain. So if that's the case, some people pass out for a split second when they're undergoing lots of G-force. Astronauts train for it, so they sort of get their body used to it, and then they also lay down to help out. So this last example, it's asking how many G's would a rocket, so if a rocket's on liftoff and it's accelerating at 75 meters per second, how would that compare in G's? So all you have to do is just always divide or compare it to 9.81. So 75 divided by 9.81 turns out to about 7.6 G's. Okay? So in that case, yeah, if it was a normal person, they'd probably be passed out if they were in that rocket. So like I was saying, quite often the astronauts, they'll lay down flat, so the blood is more horizontal, so the G-force isn't as bad as pushing straight down on the top of your head. So that's it. We'll stop there, and we're going to be starting some new stuff in the next chapter shortly.